Welcome back everyone to Professor Simo. In today's video, we're going to discuss RSA cryptography, theoretical aspects. Starting with, what is RSA? RSA is a pivotal encryption algorithm in the field of cryptography, forming the backbone of internet security. The inventors, Rivest, Shamir, Adleman, is where the name of RSA is from. RSA is one of the asymmetric crypto systems, because RSA facilitates secure online communication by utilizing a pair of keys, one public and one private. Some history about RSA. RSA algorithm emerged in the late 1970s during a time when digital communication was rapidly evolving. Before RSA, secure communication relied heavily on symmetric cryptography, which posed a significant limitation in a growing digital world. Because in symmetric encryption, we generate a key that encrypts and decrypts. But when we want to send this key to someone else, what if this channel is unsecure? What if this channel is untrusted? Here is a challenge that symmetric encryption faces. RSA, the revolutionary idea behind RSA, was the introduction of asymmetric cryptography, using two keys instead of one for enhanced security, which solved that challenge. Some of the main two solutions that RSA came up with is key distribution. Again, I've already mentioned the key distribution challenge, or a problem that symmetric encryption faces. RSA solves that challenge, which is how to exchange encryption keys securely without a pre-established secure channel. RSA is actually a multi-purpose cryptographic system, because it provides encryption, can be used for encryption, for key exchange, and even in digital authentication or digital signatures. How to verify that a message has not been altered and that it comes from a legitimate source. If I am sending you a message, I can use RSA for you to make sure that I am actually the one who sent that message. So, understanding the mechanisms of RSA, it uses two pair of keys, public and private. In the encryption, we use the public to encrypt, and in the decryption, we use the private to decrypt. What are the main components of RSA cryptography? Key generation involves selecting two large random prime numbers, then I compute their products, and then deriving the public and private keys based on this modulus. The public and private keys. The public key is derived from two large prime numbers, while the private key is derived from the same primes but remains a secret, such that the RSA algorithm is based on the practical difficulty of factoring the product of two large prime numbers, known as the RSA problem or the factoring problem. RSA in today's digital world. Where can we see RSA? On the internet. It's one of the fundamental components of internet, because it's one of the components or the backbone of security when it comes to digital communication, because we can see it in web security and in email encryptions. In the era of increasing cyber threats, RSA plays a crucial role in safeguarding sensitive information and maintaining digital trust. Why RSA stands out? What are the key strengths of RSA? It's robust security, wide acceptance, a lot of people or a lot of organizations use it. It's scalable because the keys can be generated and we just generate a key and anyone else can just use that key. Versatility beyond encryption. RSA's capability for digital signatures makes it an essential tool for data integrity and authentication. Due to the nature of public and private keys, we can use it for digital signatures, which is something that we can't see when it comes to symmetric encryption. So what's the future? What's the future hiding for us? One challenge that most, if not all, cryptographic systems face is quantum computing. So we have to come up with a quantum resistance algorithm that are also based on RSA or asymmetric encryption in general. At the same time, RSA is ongoing advancements, including increasing key sizes and exploring new mathematical approaches aimed to prolong its relevance. And the cryptography field is a dynamic field, and RSA's evolution reflects the constant push to stay ahead of emerging threats and technologies. A quick recap on what we have discussed. RSA has been a cornerstone in the field of cryptography because it revolutionized secure digital communication due to its dual key approach. While facing new challenges like quantum computing, RSA continues to adapt and remain relevant. Understanding RSA is a fundamental to grasp the broader concepts of cryptography and digital security. Stay curious and remember to always learn and keep on progressing and developing. In the next video, I'm going to show you a practical implementation of RSA. Thank you everyone for watching. This was Professor CEO.